Hey, College Algebra. Today we're going to be starting 2-4. And 2-4 is obviously operations with functions, as you can see with your graphic organizer. We're going to start with two functions whose domain is all real numbers. Okay, just to get over how to add, subtract, multiply, and divide functions. And then we'll get into some that whose domain is not all real numbers. That's where it can get a little bit trickier. Okay, so here are our functions. F of x is a linear function, x minus 3. G of x is a quadratic, x squared minus x. If I ask you to find f plus g of 3, it's not too tough, guys. We just simply take f of 3, figure out what that is, and add g of 3 to it. Okay, so f of 3, of course, would be 0. G of 3, 3 squared is 9, minus 3 is 6. So the answer to f plus g of 3 would be 6. If I ask you for f plus g of x, then we sometimes just say, what is f plus g? We kind of let off the x. F plus g would be f of x, x minus 3, plus g of x, x squared minus x. We would expect you to combine like terms, and it looks like it's going to be x squared minus 3 because x minus x goes away. Some people like to find f plus g of x first, and then when they were asked to find f plus g of 3, you might just do it right here into the f plus g function, and then take 3 squared, which is 9. 9 minus 3 is 6. You would get 6 the same way, okay? The domain is always the intersection of f's domain and g's domain, okay? So the domain of f plus g is what do the domain of f and g have in common? But since they're both all reals, you can see that the domain of this would be all reals, right? It's just a quadratic. Okay, so we're not going to get into domain a whole lot right now because, as I said, they're just all reals. F minus g of negative 6, same type thing here. I'm going to take f of negative 6 and subtract what I get when I take g of negative 6. F of negative 6 is negative 9. Negative 6 minus 3. G of negative 6 is 36 minus negative 6. That'd be 36 plus 6, right? So what's that, 42? So we have negative 51 for f minus g of negative 6. Now we have to be careful here when I take f minus g of x. I want to take my f function. And many times people just write, oh, I'm going to subtract the g function. And that would not be correct. You want to subtract the g function. So you have to put the g function in parentheses so that you subtract the entire function. The answer is x minus 3 minus x squared plus x. It looks like we get negative x squared plus 2x, right, minus 3. Okay, so I can move this over a little bit. So I can write that. Negative x squared plus 2x minus 3. So notice we said we got negative 51 when we put negative 6 in. If I put negative 6 into this function, I have the opposite of negative 6 squared plus 2 times negative 6 minus 3. So that's the opposite of 36 minus 12 minus 3. 36, 46, 46, negative 47 minus 3. I'm sorry, negative 48 minus 3, which is negative 51. Okay, so we get the right answer. If I wouldn't have distributed my negative through, I would have not gotten the right answer. Of course, the domain, again, is all reals. Okay, adding functions, subtracting functions. We're also going to be asking you to multiply and divide functions. I just want you to get used to especially how this looks, the notation of it. If f and g are right beside each other, that simply means multiply those two functions together. Okay, so I'm going to take the f function. I'm sorry, this is of 2. So I'm going to take f of 2 and multiply to it what I get when I take g of 2. f of 2 is -1. G of 2 is 2, right? 4 minus 2, so I get -2. If they ask me for f times g of x, I'm going to take f of x times g of x. And then I will have to do some FOILing. So I'll get x cubed minus x squared minus 3x squared plus 3x. That'll be x cubed minus 4x squared plus 3x. That's f times g of x. Like I said, if you want to, you can, if you're asked for f times g of 2, sometimes people take and find f times g of x and then put 2 in. 2 cubed is 8. Minus 2 squared is 4 times 4 is 16. Plus 3 times 2 is 6. So that's 8 minus 16 is -8 plus 6. Yeah, I get -2, just like I did up there. Okay? So again, doesn't matter which way you go there. F divided by g of 4. I'm going to take f of 4. Well, let's do this first. F is x minus 3 divided by g, x cubed minus x. Okay, that's my f divided by g function. F divided by g of 4. Again, I would just take f of 4 and divide what I get when I take g of 4. F of 4 is 1. G of 4 is 16 minus 4, or 12. So you get 1/12. And I notice if I put 4 in here, obviously, it's a square. Obviously, I get 4 minus 3, 1 over 6, yeah, 12. Okay? The only thing you have to be careful here, notice when we ask for the domain of f divided by g, okay, this domain was all reals as well. This domain is not all reals, guys, because the domain of f divided by g, I am not allowed to use however g of x is going to give me 0, whatever values. So I take my denominator, set it equal to 0, and I see that my domain is all reals, except x can't equal 0 and x can't equal 1. That's a way to write all reals with that big capital R with the double line right here, okay? Or, let's see, if I wanted to write it in interval notation, how would I write that? Everything except 0 and 1. If I wanted to write that in interval notation, I would write -infinity up to 0, skip over 0, everything between 0 and 1, like a half, an eighth, all those numbers, and then skip over 1, everything to infinity. That's how I'd have to write it in interval notation. That shows all real numbers except 0 and 1. Okay? So that's operations with functions when the domain is all reals, if we're lucky enough to have a domain of all reals. Okay, let's try it on your next page. Okay. All right, now, like I said, the domain is the intersection. Let's think about what happens here, okay? When I want to add f of x plus g of x, what if I wanted to add f of 0 plus g of 0? Okay, if I wanted f plus g of 0. Well, f of 0 means the y-coordinate that goes with 0. That's 5. G of 0. There's no x-coordinate of 0. There is no g of 0. Okay, so if I want to add f and g, I have to have my domain be just the x's that are in both f and g. We say in the intersection, x is in both f and g. We don't do this in Algebra 2. All right, so I'm looking. I have a -2 in f and g. Yay, that's in the domain. I don't have a 0. I have a 3 in f and g. That's it. I don't have a 1. I don't have a 4 in f, so okay. That's my domain. So the function f plus g of x is the ordered pair -2 something and 3 something. Okay? Now, what is it? -2 what? Well, I have to add the y coordinates that go with -2. F of -2 is 3. G of -2 is 1. 3 plus 1 is 4. With 3, F of 3 is 1. G of 3 is 4. 1 plus 4, 5. That's F plus G of X. Okay? F minus G of X, of course, same domain. I'm using the same function, so I took that away a little bit. But for F minus G of X then, with just that domain of the two X coordinates that are in the intersection, F minus G is -2, I'm not sure yet, and 3, I'm not sure yet. I'm going to take F of -2 and subtract G of -2. It's F minus G. 3 minus 1 is 2. I'm going to take F of 3, which is 1, and subtract G of 3, which is 4. 1 minus 4 is -3. Same thing here. When I multiply them, I'm going to have -2 something and 3 something. I'm multiplying them together this time. Okay, so I take F of -2, which is 3, times G of -2, which is 1. 3 times 1 is 3. And with the 3's, I multiply the y coordinates. 1 times 4 is 4. Okay, now I do have to be careful with the domain of F divided by G. I think it's -2 and 3 as long as I don't have 0 as the y coordinate for either one, which I don't. So luckily enough, I can say that F divided by G of X is -2. Let's see, if I take 3 divided by 1, that's 3. And 1 divided by 4, I'm just going to write a 4th. That's what F divided by G is, okay? But notice what I mean by the domain is always the intersection. When it was all reals, the intersection of all reals is all reals. That was not a big deal. Okay, the other operation we do with functions is called composition. This is F of G of X. We denoted F of G of X like this with a little circle. That's not a multiplication. Or F, the circle like that. Or I like to just write F of G of X. Okay, you can write it like that as well. This is a function of a function. Okay, so if these are my functions here, if I want G of F of -1, you're welcome to pause me and try these 3 on your own if you'd like. Okay, that might be a good idea. G of F of -1. Oh, I noticed I forgot a paren here. G of F of -1. Well, let's find F of -1. 3 times -1 minus 1. That's -3 minus 1. So I'm taking G of -4. I'm putting -4 in the G function where I'm supposed to square X and add 1. -4 squared is 16 plus 1. I get 17 for that answer. H of F of -7, if you have to write it this way, to make sure you see what you do first, I'm going to find F of -7. 3 times -7 is -21 minus 1 is -22. That's F of -7. I put that in the H function, -22 plus 1. That's -21 divided by 3 is -7. Interesting. H of F of -7, I ended up getting -7 back. It's a special kind of situation. H of F of G of 3 sounds like something we'll have to do of next video. See you in a couple. Bye.